Hello, and let me start this out in the new Camtasia. Let's go back to the beginning of this section. I am Dr. Cooper, and I am going to read this to you about adaptation so that I don't need to do it like 8 times in person. Yay! Okay. This is from the Heredity and Adaptation Science Resource, the online book that is available to you, and I will make this link available as well so you can read along. This is the section about adaptation. Adaptation. Odds are that birds native to where you live are very different from the flamingo. The flamingo is adapted to salty wetland environments. Birds are found almost everywhere in the world. Do the birds where you live look anything like this? Oh, there we go. The flamingos at the Louisville Zoo. They sure do. Take a look outside. With any luck, you'll see several kinds of birds. Flamingos have the longest legs and necks relative to body size of any bird. They can also drink hot, salty water. How did these adaptations help them live in their environment? This is page 41. There we are. Adaptations for an extreme environment. Let's travel to a totally different environment than one you live in, Antarctica. Antarctica is the windiest, coldest, and driest continent on Earth. The South Pole is located in Antarctica. About 98% of the continent is covered with ice. Antarctica harbors 45 species of birds during the year. What adaptations allow birds to survive in this extreme environment? An adaptation is an inherited trait or behavior that increases an organism's chance of surviving long enough to reproduce. Take note. What physical characteristics and behaviors help birds survive and reproduce in Antarctica? List your ideas in your notebook. Maybe I'll pause in there. Penguins! Penguins lost the ability to fly as their wings changed over time into flippers that help them fly through the ocean. Consider 2 birds that live in the Antarctic, the Adelaide penguin and the wandering albatross. Take a close look at their beaks. How might their beaks help them obtain food and raise their young? Beak. Oh wait, where's the other one? Oh, there we go. There's the penguin. It's on the next page. Makes more sense when you're looking at it as a book, right? An Adelaide penguin can toboggan faster than a running human for short distances. The penguin propels forward with its feet and uses its flippers for balance as oars. There we go. The wandering albatross has the longest wingspan of any bird, allowing it to ride the winds and glide for hours, even days. Okay, so how might their beaks help them obtain food and raise their young? Their wings and body color, how might these help? What behaviors do you think could help them survive and reproduce? Let's find out more about each of these birds. So they both range throughout the polar regions of the Southern Ocean. Beyond that, they have little in common. Adelaide, oops, wait, let me go back and double check that there wasn't text. There was not. Okay. Adelaide penguins don't fly, but they are excellent swimmers. They can swim 150 kilometers to reach food for their chicks. Penguins have very short legs, but they can walk long distances. In the early spring, they might walk 50 kilometers across the pack ice. When they find open sea, they gather food for their chicks. They can also toboggan. Tobogganing is sliding on their bellies and pushing with their feet. This saves energy on long trips across the ice. Well, the book wants me to say penguins are not very graceful walkers. They're as graceful as they need to be, darn it. So they nest in depressions in the snow lined with small stones, which keeps the eggs free from meltwater. Now the males collect those stones and pile them up in order to appeal to a mate. Adelaide penguins breed on rocky areas along the Antarctica coast. Both parents take turns incubating the eggs during the warm months of October through February. They also take turns guarding the chicks and getting them food. When mature feathers replace their down, this happens around 9 weeks of age, the chicks are ready to go to sea to feed themselves. They eat fish and krill, small shrimp-like crustaceans that live in the oceans. Of course, the warming oceans are causing the populations of krill to decrease, affecting the animals that use it for a food source. So there's a throwback to a previous unit. Penguins are at greatest risk from predators when entering or leaving the water to hunt or migrate. They jostle for position until one finally leaps or is pushed off the edge. Adelaide penguins spend the winter at sea in the pack ice. They can swim 1,200 kilometers away from their breeding sites. They gather in large groups before jumping into the sea. This increases an individual's chance of escaping predators. Their main predators are the leopard seal and the skua. The skua is a bird that steals penguin eggs and young chicks. Because remember, young animals, baby animals, and eggs are nature's popcorn. That's for me. The 1 metric ton leopard seal can easily kill any penguin that doesn't stay with the group. What other adaptations help Adelaide penguins survive? Their compact shape reduces heat loss. Dense feathers and a layer of fat insulate them. Their black and white feathers make it harder for predators to see them when they are in the water and help with warming and cooling on land. Their heart rate slows during deep dives, which helps them efficiently manage oxygen use. Their salt glands and kidneys allow them to drink seawater, which we definitely cannot. Wandering albatross. Let's check out these captions. One disadvantage of huge wings is difficulty taking off. Albatrosses usually nest on windswept heights, making a launch much easier. A young albatross can be identified by its dark feathers. It fledges or develops the wing feathers necessary for flight at about 7 to 9 months. Wandering albatross. Just like the Adelaide penguin, the wandering albatross has adaptations that allow it to survive in the extreme environment of Antarctica. But as you read, note how different the two birds are. Albatrosses can fly long distances because of the structure and length of their wings. Their wingspan is about 3.5 meters. Their shoulders lock the wings in an outstretched position. This lets them fly on wind currents without using much energy. They sometimes soar for several days, traveling thousands of kilometers to find food. The wandering albatross has 2 long tubes along its bill. These tubes give it a great sense of smell. The albatross can smell fish and squid from many kilometers away. It hunts at night, making shallow dives to catch its prey. Wandering albatrosses nest on several islands in the Antarctic Ocean. Their nesting sites are open ridges with some vegetation. They breed every other year and produce only 1 egg at a time. The male and female take turns incubating the egg. They spend more than a year raising their chick. What other adaptations help wandering albatrosses survive? They have large webbed feet for paddling. Lots of melanin in their dark flight feathers slows deterioration from salt and sunlight. They can produce an energy-rich stomach oil from the organisms they eat. This oil is an efficient source of food for chicks and gives the adults energy for their long flights. Albatrosses are rarely seen on land, gathering in colonies on remote islands to breed. Only to breed. How do adaptations arise? The wandering albatross and the Adelaide penguin are marvelously adapted to their environment. How did they acquire the adaptations that allow them to survive and reproduce? To answer that, we need to consider mutations and DNA. Mutations are one source of adaptations. A mutation is any error in an organism's DNA. If an error occurs in the DNA of an egg or sperm cell, that error will pass on to the offspring. Remember that DNA codes for proteins, which direct the structure and function of an organism. If a mutation causes a change in proteins, the organism's traits may change, though most mutations are neutral. That's chimera. If a mutation causes a change in proteins, the organism's traits may change, right? If the new trait is beneficial, it may help the organism survive longer and have more offspring. Those offspring will also have a greater chance of survival and will continue to pass on the revised DNA sequence to their offspring. The genetic mutation has resulted in an adaptation. There's 2 of them now. 2 albatrosses. The blue and yellow macaw is native to tropical areas in South America. Based on its sharp, hooked beak, what kind of food do you think it eats? There we go, sharp, hooked beak. Okay. All organisms have adaptations that allow them to survive and reproduce. Adelaide penguins live in a cold, treeless, icy environment. Their food comes from the sea. Their behavior and body shape allow them to be successful and thrive in that environment. Compare the beak of the penguin to that of the blue and yellow macaw shown above. The penguins eat fish and the macaw eats nuts and fruits. Their beaks are adaptations that make them successful in their environments. Think about a crow or a pigeon or any other bird where you live. Their behavior and body shape are not adapted to the Antarctic environment, and a penguin is not adapted to where you live. Penguins can exist only in zoos in the United States. Nor would you find a crow or a pigeon in Antarctica. It could not survive. All those adaptations originated in genetic mutations in the ancestors of these birds. Over time, they led to new species of birds. Changing environments. The fossil record provides clues about why penguins become better swimmers than flyers. Their abilities shifted when other species of animals grew more dependent on food in the sea and competition for food increased. Mutations that allowed for better swimming and diving would have enabled some penguins to survive and reproduce, eventually leading to adaptations in their wings and body shape. At the same time, these changes compromised their ability to fly. Right now, climate warming is decreasing the sea ice in Antarctica. Organisms such as krill, a major food source for penguins, feed on algae growing on the underside of the ice. Whoops. When sea ice shrinks, the growth of ice algae shrinks. This affects the population of krill, which affects the population of penguins. Adelaide penguins are adapted to sea ice. As the sea ice shrinks, populations of Adelaide penguins will shrink. They will be replaced by penguin species that are better adapted to open water. Here we go. Changes to the sea ice or frozen ocean surrounding Antarctica may threaten species that live in that extreme environment. Unlike sea ice, shelf ice is freshwater. Ice shelves are the floating masses of ice that hug the Antarctic coastline. Warming temperatures are causing ice shelves to collapse and disintegrate at a rapid pace. Adaptations develop over a long time. If the climate changes quickly, mutations and adaptations will not keep pace. What kinds of variation in Adelaide penguin structure or behavior might help them survive a changing environment? Adelaide penguin parents share egg and chick duties. How is this behavior an advantage for survival? Think questions. Number 1, list one physical trait and one behavioral trait of the Adelaide penguin that help it survive in the Antarctic. Would those 2 traits be an advantage for survival in the environment where you live? Explain. Number 2, list one physical trait and one behavioral trait of the wandering albatross that help it survive in the Antarctic. Would those 2 traits be an advantage for survival in the environment where you live? Explain. This may be the end. That is the end of that section. I will probably make a video for natural selection tomorrow. All right. Back to me. Me?